Hi guys, thanks for checking out the channel. In this video, we're going to be adding a new underfloor heating zone to an existing gas boiler central heating system. Okay, let me just give you a brief overview of this job. So this customer has just brought this house. It's all being refurbished. Now it's split into 3 floors. This is the ground floor. So currently the kitchen is actually on the 1st floor and it's all being moved downstairs to here. So what we're going to be having is kitchen units all along here on the right hand side. Now at the moment this whole ground floor is heated by radiators. So we've got a radiator there and another one behind this ply. As you can see, it is quite a large area, so I need to take in consideration the heat loss of this room, make sure the underfloor heating system that I'm selecting has got to be capable of providing enough heat to cover the heat loss of the system, which is something I'll run through a little bit later on in the video. But in the meantime, it's my first day here and I just need to drop some feeds in. So I need a hot and cold for the kitchen sink and I need to get a flow and return in for the underfloor heating manifold. So one thing you need to consider initially when you're going to be adding an underfloor heating system is how are you going to get a flow and return down to your new manifold location. Now as you can see here, we're actually like on the ground floor. There is like this basement type area at the back which they're converting. Believe it might be some sort of cinema room, but I'm quite fortunate on this job because in this area over here the existing gas boiler and cylinder and all its components are actually directly above here where this block and beam is. So what I have done is I've knocked a hole through. That's where I'm going to pipe my flow and return hot and cold to pick up for this new kitchen underfloor heating system. And then what I've done, I've just added some clips on the wall here just so I can run my pipe work down and get it located. So at the moment we're not exactly sure when a manifold's going to go, but ideally I want it to go inside here. And I believe this part of the build is actually going to be some sort of pantry. So if I can keep the underfloor heating on this side, it will mean that I haven't got to fit it in one of the kitchen units. So I'm going to get the hot and cold down, chuck it through the wall there. I've also got to get a waste pipe in, which is going to be located into the soil stack. So unfortunately we are having to use a sandy flow or one of those like domestic waste pumps. So my first job is then to get these flow and returns in for my manifold location. Now obviously the floor's all going to be raised here, so what I'm going to do is I'm actually going to dive the flow and return into the floor, which will probably be covered by a screed or some sort of concrete, and then I'm going to leave it loose up here for now because ideally, like I said, I want the manifold to go on this wall here. So the pipework I'm going to be using on this job is actually pre-insulated MLCP. Now this is actually left over from a big air source heat pump job I've been filming, so I'll hopefully post that out soon. But it's ideal in a job like this because obviously we've got to insulate our pipework now anyway, so it all comes pre-insulated. It's colour identified, so obviously we've got a hot and cold. Can't really get it too wrong, hopefully. And also, as you can see, at the moment this is quite a damp area, so if I put my copper in here, it's all going to get oxidised. It's all going to look a bit pony anyway. So I'm going to get my MLCP down, poking through into the boiler room. Once I've done that, I'll take you upstairs and show you how we're going to connect this up to the existing system. Right, I'm upstairs in the garage now, and this is where the existing boiler is and unvented cylinder. Now, unusually we have got a heat only boiler, even though the boiler is fairly new. The reason I can tell is because we've got the pipes coming off at the top and we've also got an external pump which is down there. So quite unusual. You would have expected to have a system boiler. Now the difference between a heat only and a system boiler is the pump and all the components are inside a system boiler. Makes it a little bit neater with the pipe work. Now unfortunately, as you can see, this is a right old mess. Looks like a bit of a DIY job, so this is going to be a bit more tricky to connect up, but we will find a way. So as you can see, we have got a filter which we're going to reincorporate, an external pump which we need to reuse. Now the customer has complained that the heating isn't working, so there's a good chance I'm going to replace some of these zone valves. In all honesty, I'd quite like to rip this all out and start again, but obviously that's not within my sort of budget. It's not within the scope of works that I've got to do. So I need to connect up my flow and return from my underfloor heating, which is the two 25mm MLCP pipes. Now to do that, I can't just connect straight into the flow and return here. If I was to do that, we might have issues with flow rate and flow and return temperatures. Central heating systems typically run at a difference between sort of 20 degrees between the flow and return, and underfloor heating runs typically around 7. Also, the flow rate is going to be different between the underfloor heating and the central heating. So to make sure my underfloor heating system and the central heating system continues to run as best as possible, I need to hydronically separate them. And what that realistically means is I need to either install a low loss header, or I need to cut in a close coupled T between the flow and return. That way the central heating and underfloor heating can pull the additional water it needs through the return to maintain the correct flow rates, and also to separate them to maintain the correct flow and return temperatures. So like I say, this one is going to be a bit of a pig. I'm going to try and neaten it up where I can, but it looks like it's going to be a bit of an issue. And as you can see here, we've got plastic and a flexible hose onto the central heating expansion vessel. So anyway, it's getting drained down. What I'm going to do is start cutting out some pipe work, and yeah, I'll show you how we're going to get this all connected. Okay, so straight in with the first cut. So what I'm actually doing is I'm just cutting the flow after the pump. So the first job I really need to do is get my close coupled T plumbed in. Now in an ideal world, I'll just go from here, so this flow pipe to this return pipe, but this distance between the two is actually greater than 150mm. Really, your close coupled T's want to be as close as possible. Some people say they need to be 4 times the diameter of the pipe, so I'm just worried that this is a bit too far apart. So what I've done is I've made a cut in the flow here. I'm going to remove this auto bypass and actually put a close coupled T between the two here. That means they'll be close enough together that there won't be any issues. Okay, my close coupled T's are now in, and I have got the system all up and running, and it's been a complete nightmare. So let me just run you through the work that I've done, the reason that I've done it, and the headache I've been having. So what we've got here on the left hand side, flow coming down from the boiler down through that pump. This is our flow pipe. It now tees into the return, so technically this is a loop here, just can go round and round in a circle, and this is the close coupled T. So the reason this is going to be more suitable to a central heating and underfloor heating system is we've got a pump for the central heating, a pump for the underfloor heating manifold. Both systems require a different flow rate and a different design temperature. This way they can draw from the return. Doesn't matter about any restriction in the boiler. The pumps aren't technically fighting against each other, and that means both systems can be satisfied in getting the correct flow rate, and also we can try and set the correct temperatures. So make sure these are no greater than 150mm. Obviously this is 28mm pipe work here, so did it as close as I can, just so I could still get the jaws on the press fit. So from this point here, so this is our flow pipe, it's coming along, so branched off. This is now our new central heating pump to our radiator. So this now pumps our radiators upstairs, radiators on the first floor, and also our hot water around our coil. So what you don't want to do is put it in before your underfloor heating zone or underfloor heating manifold, because that kind of defeats the point. You might as well have just run it straight from here. So what I've done is I've branched off before this pump here for my radiators. This flow now goes down to my underfloor heating manifold, where there'll be the next pump or the second pump, which is actually attached to the underfloor heating manifold. That can draw the correct flow rate that it wants, and both can work simultaneously without any issues. So what we've got here then is our return pipe. So like I say, flow and return linked here, still got our main return coming back in through the boiler, and that just runs along here. And down here I've just picked up my underfloor heating manifold return, so I've just run that behind there. That just tees in there. Now I must admit there is a bit of an issue with the hot water return from the coil. Really, that wants to be the final tee. It's always been like that, and I'm quite interested to see if it's going to be any issues with sort of back circulation, but it seems to be okay at the moment. Now I've installed one of these new pumps I've just picked up from Williams, Archer Gas. You may have seen them about, seem pretty cheap, about 60 quid, so I thought I'd give it a go. Seems to be working absolutely fine. And because these zone valves, pretty much they were absolutely knackered, all three of them, I've just swapped them all out. Now actually replacing these was fine, it's just when it came to the wiring in the wiring centre, it's a complete pig. So as you can see, it's not exactly a wiring centre at all. Now the main issues I had was the zone valves, the grey wires, none of them had permanent live, and the orange wires, they all went back to what looked like separate switch lives, which didn't really make much sense to me. Normally all your orange cables go in the same terminal, and that is where I would have linked this pump here. So I would have just put the live straight into the switch live for all these zone valves, so the pump operates every time one of these zone valves opens together or either individually. So that wasn't the case, so I've just been trying to rewire it to suit, but in all honesty, as you can see, it's such a headache working in here with all these little junction boxes. So I am going to suggest to the customer we have this all rewired into a nice wiring centre. Obviously it's not really part of the scope of the works I'm doing, but it will give me peace of mind, and we can confirm the operation is going to be totally fine once we actually add even more cables in with our underfloor heating. This is the two programs that I've got, so we've almost got like 3 zones at the moment, or 3 channels, hence why we've got 2 twin channel programmers. So I've just labelled them up as the customers just moved in, they wasn't exactly sure which switch did what. And these are also faulty, so when you're moving them along, sometimes the light doesn't light up, sometimes it doesn't activate. So I'm thinking let's get 3 channel programmer in here as well, and we can get this back to where it needs to be. So there was talk initially of going completely air source here, so that's the main reason why I decided not to go to the extremes of the pipework and neaten it all up. And it might be the reason why the customer doesn't actually go for a full rewire on the system. So we shall see. So hopefully if we get that job, we'll be back doing that. So regarding the underfloor heating, now as you can see, there isn't actually a zone valve up here for that. Quite often when you buy a manifold from these underfloor heating companies, it will actually come with a zone valve built onto the underfloor heating manifold. So that will be located downstairs in the pantry area, and then all I need to do is just drop some cables down just to pick up the wiring for the zone valve, wiring for the pump, and then we can activate that via the room thermostat and also activate the boiler. So we need to make sure regarding the wiring that when we run the underfloor heating, this pump also comes on as well, and that's part of the reason why I need to ensure that all the wiring is correct. So what I don't want is the underfloor heating manifold pump running but this pump not running at all either. So that is not going to work. So anyway, regarding the pipe work, that's pretty much all done. It was all filled up. Granted, looks like a bit of a mess, but it is all working okay, and if it was up to me, we'd get all this out and start it all again. So anyway, let's take a look at the underfloor heating systems that I'm expecting to use, have a look at the watts, etc., and I'll let you know the reason why I'm going for the system I'm going for. Okay, now we've got our first fix in, I need to decide which underfloor heating system I'm going to be using. So as you can see here on the right hand side, I've actually got a heat loss survey of the whole property. Now originally I actually turned up to do a air source heat pump quotation, so that's why I've got this in so much detail, but the room we're actually going to be looking at is a new kitchen area. As you can see, that's got a heat loss watt per meter at 52.35, so whichever underfloor heating system that I provide, it needs to be able to cover that heat loss. So I've just loaded up Omni's website, and the reason I've loaded their website up is because they're very good at telling you how many watts per meter each system will actually output. So the builder on this job wants to keep the 22mm chipboard on the floor, so I'm going to have to use an overlay system very similar to this Omni product here, the low board. Now they're usually 150mm centers, either 12 or 16mm pipe, and as you can see on the bottom here on their benchmark, it will tell you at 50 degree flow temperature you can expect 69 watts per meter. Now obviously that's a little bit high for underfloor heating, so on the right hand side they give you the information to achieve 50 watts per meter, and to achieve that you would need a 43 degree flow temperature. Now that's pretty much in line with what we need. We've got 52.35 watts per meter heat loss, and this is actually going to provide 50 watts per meter at 43 degree flow temperature. This also incorporates one TOG floor covering, which is usually a carpet, and I believe we're going to be having LVT on this job, so it should be an even higher output. So in an ideal world, you'd get a system that was insulated and grooved that was 100mm centers, but majority of the systems out there are 150mm pipe centers. So like I say, I probably won't use Omni, probably switch to another product which is similar performance but a little bit cheaper. So anyway, thank you very much for watching this video. Hope you've enjoyed it, and if you catch me on the next one, I'll show you how I'm going to install the underfloor heating on this job.